Okay, let's start. So, good evening, everyone. Myself, Ravi. So, we are here for the live session for the week 4 content. So, in this session, we will solve the problems related to transmissibility and along with the some energy dissipations through the damper. So, two topics are included in the week 4 content. So, we will solve around 7 or 8 problem. So let's start one by one. Okay. So am I audible now?
Yes, audible.
Okay. And let me share my screen. So my screen is visible.
Yes, sir, visible.
Okay. So we will solve the two questions, like two type of the problems. So the first problems is related to mainly more most of the problems related to the transmissibility. Okay. So let us start one by one. So uh, we go to the question through one by one. Okay. So in the one of the student asked a question regarding the assignment 3 question 2. Actually that question I have discussed during the last live session, and the answer was the frequency was the same as the forcing frequency, it will vibrate. I think because the in the steady state at what frequency my system will be vibrate, so it would be the forcing frequency, not for the free vibration vibrate at the natural frequency, and for the steady state it vibrate on the forcing frequency. Okay, so let us go one by one. So we have given a 50 kg laboratory experiment is to be mounted onto a table in a laboratory. Okay, the table, which is rigidly attached to the floor, is vibrating due to the operating of the other machineries. Measurements indicate the floor acceleration amplitude is the 1.2 meter per second square, and it vibrate at 100 hertz. Okay, frequency is given to us. Accurate use of equipment require that its acceleration amplitude to be limited zero point 0.6 meter per second square. Okay, what they have given, like we have some instrument, some table, like we have some, it's some table, we have mounted a instrument which weight is 50 kg. Okay, the table is attached to a floor and is vibrating due to the operation of other machineries, so there is a vibration. Okay, so there is a vibration due to some any kind of activity or on the other machineries. Okay, so the vibration amplitude is 1.2 meter per second square. Okay, uz not. Okay, and the frequency it's vibrated 100 hertz. So the this use of this machinery, whatever the machine is that, for the use of this machine, this amplitude should not be more than zero point 0.6. U double dot should not be zero point 0.6 meter per second square. Okay, so for this we need to find out the stiffness of the system with the damping ratio of zero point 0.1, so that we that our system should not exceed the limit of zero point 0.6 meter per second square. Okay, so like we have given the uz naught, is 1.2, and the response of the structure is given as u naught is zero point 0.6 meters per second square. Means the transfer, like from the acceleration, how much acceleration is allowed, from 1.2 to zero point 0.6. So the what is the transmissibility? Transmissibility is the u naught divided by the ug naught, like the response of the structure to the ground amplitude, the ground acceleration, total acceleration, whatever it is. So that would be zero point 0.6 plus 1.2. So the transmissibility is given to me is the zero point 0.5. So now using this transmissibility, I need to find out the stiffness of the system so that my system will work better. Okay, with the limitation of the zero point 0.6. So what is the transmissibility of the system? For the here we are talking absolute, anything, nothing is related to the relative. So the transmissibility of the system is given as a 1 plus 2r xi square or zeta square 1 minus r square whole r square plus 2r xi square, where r is the omega by omega n, zeta is your damping, okay, and the t is the transmissibility which is given to you zero point 0.5. Okay, t is transmissibility. So now put the value. We need to find out the r. If, like, for the finding out the stiffness for k can be found out through the m omega n square. If we have the omega n, we can find out the k because m is given to us. So so using this equation, first let us find out the r. So put this equation, t is the zero point 0.5, 1 plus how much damping? Damping is given to you zero point 0.1 damping ratio, 2 into r into zero point 0.1 square 1 minus r square square plus 2 into r into zero point 0.1 square. So please simplify this equation. Can you simplify? Anyone? You can simplify this directly. Do the square both the side. So that would be zero point 0.5 square is the 0.25, 1 plus 0.04 r square into 1 minus r square square plus 0.04 r square. Okay, if I do some mathematical simplification, so that will become 0.25, and if I will solve this equation, that will become 1 plus r power 4 minus 2r square plus 0.04 r square is equal to 1 plus 0.04 r square. Okay, if I further multiply with this, or I will do one thing, like writing like this: 1 1 plus r power 4, how much it will become? Minus 2 plus 0.4, so that will become minus 1.96 r square, and I will divide it by 0.25 in this side, so that would become 4 plus 0.16 r square. Okay, if I will take this into that side, 1.96 minus 0.16, so that would become 0.96 plus 0.16, that will be 2.12. So that final equation is the R4 minus 2.12 R square minus 3. So this is your final equation. So can you do a try to solve this equation? So if you will be able to find out the R from this equation, then we can simply find out the omega by omega n. So this is a fourth order polynomial. So this you can do, this you can try with the considering the R is equal to R4 keep at a, you can keep R is equal to 4 in this. So if you will solve this, you will be find out R is equal to R is equal to 1.758. Okay, there will be two roots or might be four roots, but all are might be negative. So the real root is this. So this can be given as omega by omega n is equal to 1.758. And what is your omega? Omega is given to you 2 pi f, which is 2 pi into 100. Okay, so if you will solve, your omega n will become 2 pi into 100 divided by 1.758. So how much it would be comes out to be? So that would become out to be 2 pi into 100, 1.758. So that would be coming out to be 357 radian per second, your omega n. So from the omega n, now you can find out the k. Okay, now using this omega n, you can find out k is equal to m omega n square. So we find out m is given to us 50 kg, and the omega n is the 357 square. So how much it would be comes out to be? So that would be coming out to be 6386927.7, or you can write it 6.37 into 10 raised to power 6 Newton per meter. Any doubt in this question up to this? So this is your stiffness. So any doubt? Am I
No,
audible?
no doubt. Understand.
Okay. So if you haven't any doubt, now you can find out the maximum deflection of the mounting. Now you have the system stiffness, or you can say you have the omega n is a 357 radian per second. Okay. So now you can find out what is the response of the system. So for the part B, what you need to do, what is the response of the system is the U naught is the P naught by K into RD. And what will be your P naught? If you remember your equation, mu double dot plus ku plus cu dot is equal to minus muz double dot. So your p is this here. Okay. So your u naught becomes minus muz naught double dot by k is your m omega n square into rd. M will cancel out, so that will be ug naught double dot divided by omega n square into rd. Rd, as we all know, 1 over 1 minus r square square plus 2 rgi square. So you know r we have calculated from the part 1. What was the r? That is the 1.758, zeta is zero point 0.1, omega n 357, ug naught 1.2. So by solving this, you can find out u naught. Anyone?
Here we have a negative sign, right?
Yeah, but the response with the amplitude, we can find out the, like, we take the mode, like, for the response maximum amplitude.
Yeah, here only I have one doubt. Uh, that U UG not double dot is there, right? 1.2 meter per second square.
Yes.
Here U naught is a negative sign means uh, suppose if you suppose if UG UG not equal to suppose 3 mm for example.
Okay.
Means it's a positive sign. I am giving a positive sign UG naught.
Okay.
While calculating U naught, I got some 2 mm.
Okay.
What could be the relation between them? Like both are relative, or I have, because I have doubt from assignment 4 only. There we have options like absolute displacement, relative displacement, like that. I got.
Okay.
Can you please explain regarding the absolute and relative?
Yes, I will explain, because I have kept those kind of questions also for finding out the absolute displacement, absolute, as well as the relative displacement. Okay. So here we are, like, we are talking about the absolute. For the relative, we have the different equation for the transmissibility. So we will discuss with that thing also. Okay.
Yes, okay.
So find out the u naught. What is the u naught? So here your u naught will be coming out very less. That will be around 4.42 into 10 raised to power minus 6 meter. Okay. So is there any doubt in this question?
Yes, I got the answer. Same.
Okay. So let us move to the another question. Okay. in this question we have given an air conditioner weight is the 1 kilonewton. Okay, and it driven by a motor which frequency is the 500 rpm. And what is the required deflection of an undamped isolator to achieve the 80% isolation? Okay, so what we are achieving isolation is, so can you tell me what is the meaning of 80% isolation? What is happening mean? Anyone here?
That means 20% will be transmissible.
Okay, so my transmissibility will be 20% because 80% of the responses diminishes by the isolator. So my transmissibility is the point 2. So I have given two cases. In the case 1, if my damping ratio is 0, so for the damping ratio 0, what is my transmissibility? Actually, what is my transmissibility? Is that 1 plus 2r j square divided by 1 minus r square whole square plus 2r j square. So if I will cap j is equal to 0, what becomes my transmissibility? It becomes 1 over 1 minus r square. Okay. So now in the question I have given the transmissibility to the point 2. Okay. So if I will write it, so that will become point 2 is equal to plus minus 1 over 1 minus r square. Okay. If I solve this, first consider positive sign. So that will be point 2 is equal to 1 over 1 minus r square. So that will become your point 2 minus point 2 r square is equal to 1. So that will become point 0.2 minus 1 is equal to point 0.2 r square. So that becomes point 0.8 is equal to negative point 0.2 r square. So that will be my root will be imaginary. Okay, so this is not applicable. So now I need to go to the negative sign. So with the negative sign, point 0.2 is equal to minus 1, 1 minus r square, which go to point 0.2 minus point 0.2 r square is equal to minus 1. So that will become 1.2 equal to zero point 0.2 r square. So what will be this? So 1.2 divided by zero point 0.2 is, so that become r square is equal to 6. So my r will becomes as a 2.45. Okay. So if I have the r, then you can find out the omega by omega n is 2.45. So omega is your 5, how much it is? 500 rpm. So that would be 2 pi by 60 into 500 divided by omega n is equal to 2.45. So you will get how much? Can anyone tell me what is the omega n? Anyone with the answer?
I think 2 pi by 60, right? There.
Oh yeah, so it would be 2 pi by 60.
It is 21.37.
So that is coming 21.37 radian per second. Okay. So now I need to find out the static deflection. So static deflection is what? UST is equal to P naught by K. So P naught is what? Mg, and K is what? M omega n square. M will cancel out. That would be G divided by omega n square. So G is 9.81, omega is 21.37 square. So how much it would be? So it would be coming out to be
0.0214.
meter. Okay. So this is the part without the damping. Now if we have given the damping also, then we need to calculate. If damping is given to you point 1, okay, then the transmissibility is the point 2, then put the value 1 plus 2 into r into point 1 square, 1 minus r square plus 2 into r into point 1 square. Okay. So if you will simplify this, your equation will becomes r4 minus 2.96 r square minus 24 is equal to 0. Okay. And if you will solve this equation, that r becomes 2.57. Okay. So now find out what is your omega n. Can you give it a try and find out the u static deflection, because I simplified all those things. So what is my omega n? Your omega,
20.373.
20.373. Okay. So r is equal to omega by omega n, which is 2 pi by 60 into 500. Omega n is equal to 2.57. So omega n coming out to be 20.4 radian per second. Okay. Now using this, you can determine the static displacement as we have calculated this one. Same you can apply u static divided by g by omega n square. So g is 9.81 and the omega n is the 20.4 square. So that your deflection would be 0.236 meter. Okay, any doubt in this question? This is the very simple kind of last kind of problems. Okay, any doubt? Like if there is nothing in the question, then the your displacement is always be absolute. So or the if the terms will come in the picture, the velocity and the displacement when we calculate, those are used in, actually those are the relative, but acceleration is always considered the absolute. So that we will discuss in the last 2 3 problems. So we are moving to the non other problem. So can you go through this question one first by yourself? Like a vehicle which is simplified in a spring system, suspension system given in the figure. If the vehicle is traveling 100 km per hour over a road whose surface is sinusoidal, varying roughness with a spatial. period of 4 meter, like, okay, like a patch of 4 meter which has some kind of roughness and the some kind of breakers, you can say, or breakers or some patches you can call. So we simplify this as a, like a sinusoidal surface, we consume idealize it, this patch. So then we need to determine the steady state magnification factor, means the transmissibility, not the, like, magnification factor is also, like, some of the authors use the transmissibility as a magnification factor, or the RD also they call it a magnification factor. For the vehicle absolute motion, okay, we are talking about the absolute motion when fully loaded and the empty. So we have two cases here. If my vehicle is, one is the fully loaded and the when the empty. So the mass of the vehicle is 1200 kilogram when fully loaded and the 400 kg when the empty. Okay. So the effective spring constant is 400 kilonewton per meter. So the damping factor is, for the fully loaded, zeta f is the point 0.4. Okay, so we need to find out the transmissibility only. Okay, so we have given some sort of assumptions here, like as the vehicle moves forward at a constant speed, so the vehicle vertical motion will be taken into the picture, and the tires are the stiff rigid, so the stiffness of the tires are ignored, can be ignored, because there is not no, well, because the tire itself has some sort of a stiffness, so we are considering it as a stiff, and the tire remain in the contact with the road. Okay, so did you understand the question? Any doubt in this question for the understanding?
No doubt.
Okay, so let's start solving it one by one. So in this, so what is given, like, we can simplify this system like that, like, this is my support kind of system, a spring, a damper, and a mass is applied at here, so which displacement is u, but at the same time my support is also motion, which is z t. Okay, so here we are simplifying this equation, z t. So if I will write the equation for this, mass, stiffness k, and c, some sort of derivation may have done in the live session or in the week content, week 4 content also, but we are refining of your concept. So if I will write this equation, what is my equation? So that would be the mu double dot plus k into u minus z plus c into u dot minus z dot is equal to 0. Did you understand why I consider only the, in this, the relative, not in the acceleration, not in the mass term? Anyone here? Because, yes, anyone? Anyone is there to give the answer? Why I consider u minus z? Why I don't consider the u double dot minus z double dot?
I didn't understand.
What is?
No, I didn't understand.
No. Did you understand why I write? Do you know this equation? Why I write this equation? Why I don't write this equation like that? Mu double dot minus z double dot t plus k into u minus z plus c into u dot minus z dot. Why I don't write this equation? I write this one and this is not, because my acceleration would always be considered through the absolute, not the relative, and my displacement displacement and velocity always relative, and my acceleration is always in absolute or total acceleration. Okay, so that's why I will not use this, I will use this. Okay, so if write this equation further, so how what it becomes, mu double dot plus ku plus cu dot is equal to kz plus cz dot. Now you can solve this equation. This kind of solution is given to you in the week 4 content also. So you can consider your zt is given to you. Zt is as a z naught sine omega t, because it's a sinusoidal function. Okay, so z naught is given to you how much? Z naught is given not given to you. So sine omega t and omega we will calculate whenever it is required. Okay, so if we put this z t is equal to z sine omega t, and z dot is the z naught omega cos omega t. Okay, if I will put this into the equation, mu double dot ku plus cu dot is equal to k into z naught sine omega t plus c z naught omega into cos omega t. Okay, and if I will consider, I can write this as a z naught square of k square plus c into omega square into sine omega t plus theta. If I will consider this one as a some constant r cos theta, and this one as a r sine theta, then you will simplify this, so you can get this. So now for this kind of equation, what is your solution? What is the response u? So we representing this as a p. Okay, so we can write it as a, so the solution of mu double dot plus ku plus cu dot into p sine omega t plus theta, which becomes u becomes p by k into rd, as we all know. So p by k, and what is your rd? Your rd is 1 minus r square whole square plus 2rj, and what is your p? Is this one. Okay, so if I will put this z naught k square c square omega square divided by k into 1 minus r square square plus 2rj square. Okay, so the whole thing I can convert. If I will take k outside, okay, so that become u by z naught, and k taken from the outside from this, so that will be cancel out. So that whole things become, if you will simplify this, that becomes 1 plus 2rj square 1 minus r square square plus 2rj square, and where r is your omega by omega n. So here this u is the absolute. And for the relative also, we will discuss in the another problem. So this is the transmissibility you need to find out in this part. So for this, you have given the, you need to find out the uh, omega and omega n. So the speed of the vehicle is given to you 100 km per hour. So that can be written as a 27.78 meter per second. Spatial distance d is given to you 4 meter. So what is the time duration td is d by v. So that would be 4 divided by 27.78. So that will comes out to be 0.144 second. So what is my forcing frequency? Omega बराबर 2 pi by td. So 2 pi by td is the 0.144. So the my forcing frequency become 43.63 radian per second. Okay, and the stiffness of the system is given 400 kilonewton per meter. Mass of the vehicle is given to you 400 kg. Okay, so the thing you need to determine omega n, mass 400 when it is the empty, and mass is 1200 kg when it is fully loaded. So omega n of empty is k by m, which is k is the 410 raised to power 3 and m is the 400. So that will be cancel out. So that will come out to be 31.62 radian per second. And omega n fully,
Their stiffness will be equivalent stiffness, right?
yes, that k by 2, so that is the k.
Okay, okay.
Okay, in this system, if you will look into this, it is given to us the k by 2. So that will become k. So for the fully, that would have become 400 into 10 raised to power 3 divided by 1200. So that will be cancel out. So that will you will get is 18.25 radian per second. Okay. So I have the omega n for the fully and empty. Can my damping ratio would be different for the fully and empty?
What?
Damping ratio would be different or it would be same?
Damp, damping is different.
Okay, damping ratio would be different, no? Okay. So the damping ratio for the fully loaded vehicle is given to us zero point 0.4. So as I know, damping is given by C over C critical, and C is given by us as a uh, C. So C critical is the 2 under root m k. So the here in the both the cases k is the constant. So I can write it like xi under root m over c by 2 under root k is a constant c1. So xi1 under root m1 is equal to xi2 under root m2. So for the xi for the fully loaded into mf, xi for the empty into m of empty. So xi of fully loaded is given to you zero point 0.4, mass of fully loaded is given to you 1200, xi of empty we need to calculate it, we need to calculate, and mass is 400 kilogram. So can you calculate what is my xi empty? What would be my xi empty?
0.692.
Okay, so 0.693 or 2, whatever you are getting. So now I have everything. Now I need to determine the transmissibility for the empty vehicle and the transmissibility for the fully loaded. So the transmissibility we have calculated formulation is the 1 plus 2 r xi square over 1 minus r square plus 2 r xi. Okay, so for the empty, xi is 0.693 and r we need to calculate. So omega we calculated for this forcing frequency is the 43.63 and omega n for empty was the 31.62. So you can find out r 43.63, 31.62. Same for the fully loaded. Your damping is for fully loaded is the zero point 0.4. Your omega is the 43.63. Your omega for the full omega n for the fully loaded is the 18.25. So your r would be omega by omega n is 43.63 divided by 18.25. So can you calculate the transmissibility for the both the system? Give a try. So R for this system is coming out to be 1.3798. You can take it to 1.38, and for this it is coming out to be 2.39. So anyone with the answer? What is my T empty and what is my T fully? If you have any doubt, you can ask here in this question. If you are unable to understand the problem,
TMT is 1.0213.
okay, 1.20. Yeah, some decimal places is okay. So 1.02 I am getting, and for the MPD fully loaded,
It is 0.424.
okay, it is 0.424. Good. So is there any doubt in this question? Anyone has any doubt? If not, then we are moving to some two questions we are here taking for the energy dissipation. Then we will talk about the absolute and the relative. Okay. So this is a like a simple question. A energy dissipated by a viscous damping during a cycle of motion of an STF system due to force is E. Like during a cycle for the STF system, the energy dissipation is the E. So determine the what factor of the energy dissipation during a cycle will change if my forcing frequency, like first my omega 1 is the omega, first case, my displacement u1 naught is the u naught. So what happens if my omega 2 becomes 2 omega, okay, frequency is doubled, and the displacement amplitude of the system is halved, मतलब half. So and u2 naught is the u naught by 2, and all the all other parameter c is same, c1 is equal to c, c2 is equal to c. So do you know what is the expression for the e? Anyone? If you know the expression for the e, then it will be very simpler, otherwise we will derive this. Anyone knows?
Pi c omega unit square.
Okay, so you do you know how do we calculated it? It is
Yes, in videos only we get.
okay. So that is given in the your content. So your e, like I will write in shortly, like e is calculated it as a f of tx, okay, for the one cycle, which is your 2 pi by omega. And if your u is the u naught sine omega t, then your u dot will become u naught omega sine omega, sorry, cos omega t. Okay, let me write it clearly. Cos omega t. So you can write it like a f u dot dt, and f, you know what is your f, c into u dot. Okay, so that will become f is replaced by c into u dot dt. So that would become your 0 to 2 pi by omega c into u naught square omega square cos omega t square dt. Okay, and if you will solve this, whatever the one student told us, your equation energy will be pi omega c into u naught square e. If so, for e1 is my whatever it is same, pi omega c into u naught square. So e2 would be pi into 2 omega into c into u naught by 2 square. So that would become as a pi omega c u naught square by 2. So the e1 by e2 becomes 2. So my e2 would be half of the energy. So my energy is becomes half if I do these systems. So this is a very simple question. These are the some objective kind of questions. If you remember this equation, then it is a nothing. Okay. Any doubt in this question? Anyone? If not, then we have given a same kind of question, but in this we have given a block of mass 1 kg is attached to a spring K, and the block is displaced 20 from the equilibrium and released from the rest. Okay, like a mass and a spring, and it's give a 20 initial displacement and then the release. The block is in a fluid. Okay, so the block is in the fluid. So let us suppose there is some sort of fluid. So it is in the fluid. Okay, so the block is in the fluid where the drag force is given by the Ft. So when the mass is given to this initial displacement and then the leave, then there is a drag force by the fluid Fd, which is given by Cd into U dot into U dot. So we need to find out what is the dissipation of the approximate number of cycle before the amplitude is reduced to 50 Okay, so the energy dissipated by this damper is given by this one. So we need to finding out the damping ratio. How do we can find out? Okay, so dissipation, first we need to find out what is the energy dissipation by this force Ft. So can you find out? Like we have a spring mass system in a fluid, we are giving an initial displacement of 20 and then we release. So there is a damping force through the water. So this water damping force is represented by the, in terms of the drag coefficient, and u dot and u dot. Okay, u dot square generally. So we need to find out how much cycle it will take to reduce my amplitude to 50 final amplitude. Okay, so I need to find out the damping, like the energy dissipation by this. So E is given by, as we discussed, from 0 to 2 pi by omega f dx, or 0 to 2 pi by omega f is given by this cd into u dot into u dot, and dx we also write it u dot dt. Okay, and u we know, we write it u is equal to sine omega t. Okay, so u dot will become u naught omega cos omega t. Okay, so if I will put energy dissipation 0 to 2 pi by omega, so cd into, if I will put u dot there, so that becomes u naught cube omega cube cos omega t square into cos omega t dt. So we need to solve this. Okay, so the cos, any
Uh,
doubt?
Here, how can we assume like cos omega t for here we are assuming right u equal to u naught sine omega t.
Yes,
Is there is no uh, is that we in problem we didn't he didn't give right sine omega t. How can we assume sine?
harmonic function.
Okay, he is not mentioned right.
Yeah, we are considering a harmonic function.
Okay, okay.
Like if any system, you write your response in terms of the some p naught by k rd sine omega t final. Did you remember this?
Ah, yes, yes.
So that's why we are taking this as a u naught sine omega t. So u naught is your u static multiply with the rd and then some sine. Did you got it?
Okay, okay.
Okay. So now solve this. So here my function cos omega t is always a even function. Okay. So for the even function, I can write it as a 0 to 2 pi by omega cd u naught cube omega cube cos cube omega t dt. So as a even function, I can write it into the, I can divide into cycles also this. So for the even function, I can write it 4 times 0 to pi by 2 omega cd u naught cube omega cube cos omega t dt. Okay. So this is a, for the even function, for even function, if my 0 to pi by 2 cos n cos t power n into dt is there, so my solution would be, if n is odd, if my n is odd, then I can write it as a n minus 1, n minus 3, n minus 5, so on, divided by n, n minus 2, n minus 4, so on. So here I have pi by 2 omega cos cube omega t dt. So that will become 3 minus 1 over 3 into 3 minus 2. Okay. And that omega t is also there, variable omega t. So if we do the integral of this, so that will come into the divide. Okay. So that will become 2 by 3 omega, and I will replace it with the ed. So that becomes 4 cd u naught cube omega cube into 2 by 3 omega. So omega will cancel out. So that becomes 8 by 3 cd u naught cube omega square. So this is my energy dissipation from the fluid flow damping. Okay. So this, if I equate, like generally if I convert my system, like rather than my fluid, if I will convert it to a spring and a damper system mass, then there is a dissipation of the energy which we calculated in our last question. That was the pi c omega u naught square. Okay. So I can equate this energy to this one. This energy would be this one. Okay. If I will equate this, E equal to ED, so that will be pi c omega u naught square is equal to 8 by 3 cd u naught cube omega square. Okay. And cd is given me to as a 0.86 newton second square by meter. Okay. So from here I can find out the value of c. So my c is becomes,
Hello.
yes,
Uh, Here we have derived one thing in fluid. In fluid, can you please explain what is ED? ED means here energy dissipation
through the
of the
fluid,
system,
through the fluid.
energy distribution of the system through the fluid.
Yes,
Okay, then here we are equating with pi c omega u naught square.
yes.
Means, can you help
Like
me?
if we have a system like this system
Okay.
in which we have C and K and M. So in this my system, how my energy will dissipate with this equation, my energy will dissipate.
Yes, yes.
Okay.
Okay.
So my overall energy I am equating with this. Like my whatever energy is E dissipating by this one, I am equating this. Like either this system or the fluid system. I am equating like converting fluid system to the damper system
Oh, okay, okay.
for the solving. Because we have the solution for the spring mass damper system.
Yes, yes.
So that's why we are converting from damper like fluid drag system to the spring mass damper system. So that's why we are equating this.
Okay.
Okay. So our C is become like this. Like my, if I will, like for the fluid, from the fluid system where the fluid was there to this system, my C should be this one, 8 by 3 CD U naught cube omega square. This one. Here the CD was
Yeah,
this.
understand. Yeah, yes.
Okay. So now put the CD value. Okay. So CD is given to you. So what is my damping ratio? Xi is equal to C by CR. Okay. So C critical is given to you as a 2 m by m into K. Okay. And mass and stiffness is given to you. Mass is given to you as a 1 kg, and stiffness is given to you 3 into 10 raised to power 5, 2 into 1 into 3 into 10 raised to power 5. So that will be C critical. Okay. And the my C would be 8 by 3 into CD is the 0.86, which is given into the question. 0.86 u naught, I don't know what is the, so this will be a variable. Sorry, here from this that will be cancel out, that is also one power. So that will becomes only u naught. Okay. 0.86 into u naught into omega square. So omega square is given to me because the frequency is given here. Omega square is the omega n directly. So my omega n is the k by m. So k is the, what is my k, into 3 into 10 raised to power 5. M is 1. So that will comes out to be 547.72 radian per second. So if I will
Here,
calculate,
omega is omega n square.
what is,
Omega, here omega equal to omega n.
because my free vibration na, like I am giving the initial displacement 20 and then I am releasing it.
Okay, okay.
So my damping will comes out to be J will become C over CR. So C is 8 by 3.86 U naught 547.72 square divided by 2 into 3 into 10 raised to power 5. Okay. If I solve this, is there anything is remaining in this expression? 8 by 3 CD u naught. There is one term pi is also there because we equating this term. Okay. 3 pi. So if you will solve this, your damping will comes out to be 0.365 u naught. Did you get it? Like if you want to do calculation, you can do this. Let me do the calculation. 8 into 0.86. So did you get it? Any doubt up to this point? Any doubt?
Okay, no doubt.
Okay. If not, then my damping ratio is coming out to be 0.365 u naught. So do you know the logarithmic decrement? What is my logarithm? Because the question is asked like my u u1 is the 20 mm and my un is the 15 mm. So I need to find out how much cycle it will take to reach there. Okay. So do you know the logarithmic decrement? Ln ui over ui plus 1 is given to me 2 pi xi for the one cycle, or I can write it for the nth cycle ln ui over like u1 to like un is 2 pi n j xi. Okay. So ln log ui is the 20 mm, un is the 50 mm, is the 2 pi n, and xi is what? 0.365 u naught. And u naught is what is my u naught? Is the 20 mm, which is given initially. Okay. So that is log 20 by 15 is equal to 2 pi 0.365 into 20, because all in the units are in the meter, so I'm converting into the meter. And okay, so it will becomes ln 20 by 15 into 1 upon 2 pi 0.365 into 20 into 10 raised to power minus 3 into n. So can you get me the answer? Can you get the answer for me?
Can you please go for a problem? Actually, 20 meters is given 20 meters. No?
No,
20.
20 mm.
35. 35.
35 cycle.
Hmm.
Let me cross check what I'm getting. So I'm getting n is equal to 6.27 7 cycles. How you are getting 35?
Okay, maybe numerical calculation mistake. Maybe.
Yes, might be. So there are two way. Either you can get it by the finding out directly n, or you can logarithmic decrement by one cycle. Like you have the ui initially 20, then you can find out ui plus 1 with the one cycle. So then ui plus 1 will comes out to be around 19. Then for the next cycle, your ui become the 19. Then using that ui, you can again find out the ui plus 1. So that will be something 18. So that's how you can find out. So here I'm doing directly. So you are getting the n is equal to 7. So any doubt in this question? Anyone has any doubt in this problem?
This when is the approximation 2 pi psi can be used up to what limits of psi?
2 pi psi, like yeah, you can use
Because now
your
we are already crossing the 20%. Now we are going 360, the 36.5% actually. So I want to know
no 30 damping is 36.5. How much damping is?
0.365.
No,
No,
no, no,
no, no,
not
no, if you will multiply
That
with
is
the 20,
you not right.
that would be the very less 0.365, 20 into 20 in the meter, if you will keep it.
oh, okay, okay, okay. Okay,
So that is
okay.
very less. If I will multiply with the 100 in the percentage, so that is less than 1%. So you can use it,
Okay,
simplify.
okay, okay. I was thinking 0.365. Why we are using like that? I
Oh,
was
okay,
thinking.
okay, okay. So any doubt up to this?
So I have a basic doubt here. 20 into 10 power minus 3, is that right?
Yes,
We, here we 20 mm, he has given 20 mm.
yes,
Okay, then where is the, what is the need to conversion here? 20 into 10 power minus 3.
because all the units are in the meter, everything in the SI units.
Okay, okay.
Here you can do also, but here that will be cancel out.
Ah, okay, okay,
But here there is no nothing is to be cancel out, so that's why we need to do multiplication.
okay.
Should we move to the next question or any doubt is still there?
Can go to next part.
Okay, so we will move to the next question. So now it's come to the some your relative, whatever you have doubt in the initially, how to find the relative and the absolute. So you have given a question. A 35 kg block is connected to a support through a spring which stiffness is given to you 1.4 into 10 raised to power 6 Newton per meter. In parallel with there is a dashpot damping which is the 1.8 into 10 raised to power 3 Newton second per meter. The support is given in a harmonic displacement of amplitude of 10 mm with a frequency of the 35 Hz. So what is the steady state amplitude absolute of the displacement of the block? Absolute. Because for the absolute, we have write initially a equation in the uh, vehicle problem, that was the mu double dot plus k into u minus z plus c into u minus z. That was the equation for the absolute, where u is your absolute. In the second part, we need to find out the steady state displacement of the block relative to its support. Okay, relative to its support, where we have done like this. So let us suppose that was the u, that was z. So my u relative would be u minus z. Okay. So now this equation I will convert into the relative. So that would become, I replace u with the, so my u will replace with the ur plus z. So m ur plus z double dot plus k into ur plus c into ur dash dot is equal to 0. So in this equation, my mur double dot plus kur plus cur dot becomes minus mz double dot. Okay. So in this, so in the absolute and the relative, what is the difference? My differential equation is the mu double dot plus ku plus cu dot is the kz plus cz dot, and in this the relative mur kur cu dot r is the minus mz double dot. So that is the difference. So if you will solve this, so your transmissibility in this system u by z comes to be like that: 1 plus 2r xi square over 1 minus r square square plus 2r xi. And in this system, if you will solve, your ur divided by z is coming out to be, it coming out to be r square divided by 1 minus r square square plus 2r xi square. Only difference in the numerator, not the denominator. So in this, your this is r square, and this you have the term like this. Okay. So did you get the difference in the relative and the absolute?
Yes, yes,
Okay. So now your assignment question will be solved easily, I think.
yes. Thank you.
So here we will solve. First, let us solve the tutorial questions, then you can go with the assignment questions. So here what they have given to us. So let us go with the part 1. So the part 1, we need to determine the absolute displacement. So in this, for this absolute, what I require, r and damping. Okay. So for the r, I need omega by omega n. So omega is given me the frequency of 35 hertz. So that become 2 pi into 10, and omega n become the k by m, which is k is the 1.4 into 10 raised to power 6 divided by the 35. So can you tell me what is my omega n? Not the omega n, directly tell me the r.
1.57 into 10 power minus 3.
Let me check. Sorry, the frequency omega is given to you at a 35 hertz.
Okay.
So that would be comes around 1.1. Anyone?
5.49 into 10 power minus 3.
So
5.5 into 10 power minus 3.
no, no, you are doing some miscalculation. Omega is your 2 pi into 35, and your omega n is the square root 1.4 into 10 raised to power 6 divided by 35.
Okay, I think I missed the root. Okay, 1.1, huh?
Yes.
Yes,
1.1.
yes.
1.1.
And find out the damping ratio, C over C critical. So C is given to you 1.8 into 10 raised to power 3, and C critical, you know what is 2 m omega. So 1.8 into 10 raised to power 3 into 2 into 35 into omega n is your 1.4 10 raised to power 6 by 35. That is coming around 0.128.
Yes.
Yes,
Okay.
0.128.
So now you have the Z. Z is given to you 10 mm. So you can find out the U. What is your U total, like the absolute? Z is the 10 mm into multiply with this the transmissibility. 1 plus 2 into R is your 1.1. J is your 0.1285 square. 1 minus 1.1 square plus 2 into 1.1 into 0.1285 square. So how much you are getting? Your U total or U absolute? Anyone with the answer?
29.574.
Okay, you are getting 29.574. I am getting like maybe some decimal. This is so 29.44 I am getting. That is okay because I have done actually this as I have actually 0.129. So due to that I think I am getting 29.44. So this is for the absolute. Now find out the for the part 2, relative. Relative displacement. So in this U relative you can find out 10 into R is your 1.1 square over 1 minus 1.1 square plus 2 into 1.1 into 0.185 square. So what you are getting?
31.883.
31.
Yes.
I am getting 34.3. How much it can be so much difference? Let me check. I'm getting 34.3 mm. Check your calculation. Either I think I'm using 0.129, so that's why I'm getting this. That might be the reason. Okay, is there any doubt in this question?
Yeah, I got same answer. I didn't square that R. I
Okay,
have
okay, okay.
taken only R. Okay.
Oh,
Hello.
yes,
Sir, actually, you this problem solving session, the questions are like in video only, right?
yes.
Do you have any PDF format with these questions? Because in the in problem in our session we can't note down that questions. Just we are listening.
So
Do we have?
after the session, I am uploading the material. So what do you want prior to the session?
Yeah,
No, no,
this
no. I think he's not aware. Like you're uploading the written document transcript also. It is being uploaded.
okay. This problem solving session whole
Yes,
PDF.
yes.
Okay.
Yes.
Everything, video and PDF. Along with that, I am uploading PPT also because some of them might confuse through the writing. So that's why I am uploading the PPT also. So you can go through that also.
Yeah, it's
PPT
great.
I have not seen actually. That on Excel sheet link was there. There I have seen only this transcript only.
No, both the documents for the week one,
Okay.
you have each week you will be find two documents. One is this the whatever the class notes, and the another is the same. Like the all the questions are same, but I have prepared for them PPT so that I am also uploading for that.
Okay.
Yeah, it's great.
So you can go through any of the like in the PPT there might be one question less or one more, but almost same. So in the question 7, same kind of problems we have a problem we have done in the last class. In that we calculate the RD and then we find out the stress at the column. Same kind of problem. So whatever calculation we performed in the last class, we do not need to perform here because I have given already you the K equivalent, U static, U naught, omega and omega. So you don't need to even the R ratio. So you don't need to like the invest waste your time to the calculating the things again. So you need to do find out the transmissibility in this question. First question is the transmissibility. Then you need to find out the stress in the columns. So transmissibility, whenever if they will ask you the relative, then it will be you go to the relative. But whenever it comes to the transmissibility, it means the absolute always. Okay. When it comes to the stress, so in the column, when will be the stress generated? If I will consider absolute or if I will consider the relative. I'm audible. Anyone is there?
Both are same, right?
No, if I will consider the relative, then only my column will generate the stresses. If I will take the absolute, then actually that stress will develop, but that is that I need to like rigid motion, I need to be separate from that. My column will deform only due to the relative motion, relative displacement. Did you get it?
Yeah, understood. Yes.
So for the first question, find out the transmissibility. You have the for the finding of the transmissibility, you need the damping ratio, which is given to you 5%, and for the the ratio R which is given to you 0.71, or you can yeah, 0.71, so you can use that to find out the transmissibility for the first question. So you have given the damping 0.05, R is 0.709, so find out the transmissibility 1 plus, use this xi and R value, please find the transmissibility.
That is 2.
Yes, that is coming out to be 2. And then in the next part, part B, find out the relative transmissibility, and then find out the relative displacement, and then using that find out the. So in the part B, I need to find out the U relative, which will be U naught into TR. So in this TR would be U naught into R square divided by 1 minus R square square plus 2R j square. Okay. So can you, and the U naught is given to you in the question, this one 4.5. Okay. So U has given to you 4.5 sine 5.3 t. So your U naught is 4.5. Is it in the mm? So find out the UR. After finding out the UR, you need to find out the stress in the column. So first find out the shear force in the column. So the shear force will come out to be whatever we find out in the last class, whatever the way is the K time the UR for the whole both the columns. For the single column, it will be divided by 2, because all both the columns had the same stiffness. If it would be the different, then the K would be 3I by L cube for the one column. Vmax, after finding out the Vmax, you can find out M, which is the Vmax time the length, which is 4.5. And after finding out the M, you can find out the stress, M by Z, and Z is your 67 into 10 raised to power minus 6. So anyone with the UR?
4.502.
Yeah, it is coming nearly same. 4.5 mm. So what is my V maximum? Stiffness. Let me write the stiffness so that you can you write stiffness K is 398,222.22 Newton meter. So use this stiffness, find out the V maximum that would be comes around to be 896 Newton. And then if you will do this 896 into 4.5, you will get 4032 Newton meter. So can you give me the stress, bending stress? Anyone with the answer?
I didn't understand. U r equal to 4.5 meter. U
Mm.
naught is
This is
4.5.
not the meter.
But why U naught and U r both are same?
Because transmissibility is coming out to be one.
100%.
Yes.
100%.
It is 60.17.
Yes. So it is coming out to be 60.2 MPa. Okay. So now in the last question, that is like a we have solely one question like a empty wheel or the fully loaded wheel where we get go to the transmissibility. Okay. So here this is not about the uh, like only the transmissibility. We need to find out like if a breakers is in the way in the breakers are there, and my property of the vehicle is like that, stiffness is this, damping is this, and I'm traveling at a speed of this. So how much displacement, how much uh, response or the acceleration of the vehicle would be there, because acceleration is important from the point of view of the comfort for the designing of the, like if you find out the very expensive vehicle, they design according to that. So that's why you don't feel that much acceleration though, so that will feel the comfort to the passenger or the driver. So same kind of the question is there. So we have a like a, you can consider it as a bump, like continuous bump, which is like a one cycle with the magnitude is the your function y is given to you the 0.01 sine omega t. You can consider anything y z whatever you want, meter. So this is the excitation to this we are giving, y t is the 0.01 sine omega t. So how much acceleration of this vehicle will feel, we need to determine. So you have given the mass 500 kg, you have given stiffness 4 into 10 raised to power 5 Newton per meter, you have given the damping coefficient is 3000 Newton second meter square, and you have given the velocity 52 meter per second. So first find out the transmissibility, and transmissibility will give you the displacement, total absolute displacement at the top, u naught time the tr. Okay. And the u dot tr, you can find out the acceleration, u double dot would be the omega n square times the ut. So this will be my acceleration at the top. So for this, what is my forcing frequency first? So that time period td, how much time it will take, the span is given 2.5. So the one cycle td is given me to the 2.5 divided by the 52 second is the TD. So omega would be 2 pi by TD. So 2 pi by TD is the 52, 52 that would comes out to be 130.69 radian per second. Same you can find out the omega n k by m, which will comes out to be 4 into 10 raised to power 5 into 500. So that is coming out to be 28.28 radian per second. So using this, my R will comes out to be omega by omega n. So that would be 130.69 to 28.28. So it will comes out to be 4.625. So if the R, now we need to calculate the damping ratio. So that will come out to be C over C critical. C is given me to 3000. C critical is 2 into K into M. So that will be 3000 by 2 into K is 4 into 10 raised to power 5. M is 500. So that will be coming around 0.106. So now you have R, you have Chi. Find out the transmissibility. Anyone with the answer? Anyone with the transmissibility?
It is 0.068.
Yes, 0.069. So that would be UT divided by the U naught, and U naught is given to you 0.01 meter, or you can say it to be in mm, but we don't need to change it. So U total will comes out to be 0.01 into 0.069. So that would be 6.9 10 raised to power minus 4 meter. So your acceleration at the top would be omega n square times ut. So that would be 6.9 into 10 raised to power minus 4 into omega. What is my omega? N is the
28.28.
yes 28. But I think here we need to use omega, not the omega n, because my forcing uh, like due to forcing my displacement is coming this, so my omega square would be there, so that would be 6.9 into 10 raised to power minus 4 into that 130.69 square, so that would be 11.73 meter per second square. So that's how you can find out acceleration amplitude of the vehicle.
There, that function is. Did he given the function? I didn't get in initially. Y
Yes,
equal to the function is there, right?
yes, so that's why it will come for the acceleration. If you will calculate the acceleration of this, then it will become, that's why we are using, so y, let us write it here. Your yt is given to you 0.01 sine omega t. So your y double dot t is become 0.01 omega square sine omega t, some negative sign. Okay. So your acceleration, because transmissibility is same for the acceleration or the either displacement. So ut divided by y double dot t maximum is your transmissibility, which was the 0.069. So your u double dot t will become 0.069 into 0.01 into omega is the 130.69 square. Negative because we are considering the positive absolute, so that will become 11.73. Yes. Now you have any doubt?
It's clear.
It's clear. Okay. So in the all the questions, if you have any doubt in all 8 questions, any doubt in this question, so I think assignments questions are only you can solve this week, because all the questions are same kind of the nature. Still you are
So
having
the
any doubt?
PDF of this one will be available today, no? After a few couple of hours.
Yeah.
PDF.
After, yeah, that will be available today. PDF and the video as well as both will be available today. So any doubt in this question? Any of the questions we have discussed so far, 8 questions? So this damping kind of question, is you have any doubt, something relative? Damping related, I think there is no nothing is there in the week 4 content. One question is you need to find from the some curve, you need to find out the damping ratio. Is that kind of question is there? And except this, I think everything is there in the with the uh, transmissibility. So did you get it? The week 3 contained the question to answer.
Yes, yes. Yeah.
So that was correct or wrong?
Correct, correct. I
How
got correct.
how do you get it?
Actually, I guess that like we have only steady state response after uh, 10 times the natural period. Like I guess like okay, we can have a steady state response only. In steady state response, we will have a omega.
Yes, nice.
Like that, I have put.
Yes, if it still it will be have the like 5 cycle or 10 cycle or 15 cycle up to the
But
diminishes of the
but
response.
but I didn't get even. Uh, Suppose we can't say how after 10 times we have only steady state response.
Because
How can we say?
because your transition, the whatever the what we call transient response is not up to that much time.
Then can you give me the uh, how much cycle? Like can you tell me?
No, if you will plot it, like take any coefficient a b c something, okay,
Okay,
and
okay,
then up to initially 1 or 2 cycle, not up to 1 or 2 cycle also, that will start converging. your solution.
Okay. We uh, shall we go through like that?
Which one like that?
Means after one or two cycles, we can have a compulsory steady state response.
No, this is a not a like every each and every in one and two cycle. That also depend on some parametric. What is your time period also? What is your initial state, initial displacement? Those things also affect, but not that much. Like it won't be like after 10 cycle your time period would be like that. Not. So there is nothing thumb rule like that. It will be fixed for the one cycle. After one cycle, your that will be the response. So that depend on the equation. If you will plot it most of the time, because that's why we are in the force vibration, we are always focus on the steady state, because the transient response diminishes as soon as it goes down.
Yes, I also like thought we have to plot this in MATLAB
Yes,
so that we will get. But I don't have time at that time.
that was the some like common sense question, not the
Yes,
calculation.
yes, yeah, I have same, but just I want
To check,
full marks
yeah,
like.
which the question.
Uh,
And there was one question was regarding someone the 4M. Some of them has doubt like how do we consider that the in the inertia, so that was okay.
for me, it's okay. In the live session only, I have asked you
Okay, so
regarding
then it
that.
was, then you got it is correct.
Yeah, yeah, I got it correct.
Nice, nice. So like one of the student asked that you ask on the form itself, na, like regarding.
Regarding this 10 after 10 natural cycles only, I have asked.
Yeah, because I have seen that question today itself, but I thought like I have given the answer in the hint in the live session. So that's why I think like because that I seen it today, so that last date was over already. So that's
Okay,
why I think like let me discuss in the live session during, so that would be better.
okay,
So
okay.
so do you have any doubt other than this, or any suggestion regarding the live session, like anything you want to include so that you will be all of you, it will be beneficial for you.
From my side, this type of you have we have discussed, right, a fluid type
Yes,
of.
yes,
Uh,
yes.
Actually, my research is related to I want to reduce the amplitudes for a frames. This type of practical oriented problems should be more from
Okay.
my side. Not in problem solving session.
Yeah.
If possible, do we have suggestions from any textbook or regarding this type of practical problems? Do we have any textbooks or any problem related PDFs?
Any textbook? I don't know, but if I will get it, I will definitely suggest you. If I
Okay,
will find related to the experimental purpose, because this part normally in the free vibration and all these are the mechanical part normally. These
okay,
kind of problems are. So over civil part will start soon. Like these, I also in the civil we use this, but these kind of problems like the vehicles and the whatever we look into the
yes.
table, and these are not dealing with us.
It was
So
very much. It is very much interested to do this type of problems like practical, fluid. We can convert this
fluid
uh,
damping to the
uh,
that
yes,
system, because
yes,
we don't know the solution for the fluid damper, so we
yes,
convert it into that equivalent so that we can find out the energy, how do we dissipate. So that's how these things work.
yes, yes, yes.
So the
Great.
problems levels
This,
are okay.
Yes, yes, super.
Yes, anyone another has someone has.
yeah, sir. This class notes, no, only video transcript is available, or
Everything is available.
no, 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 not this live session. The actual classes, I'm seeing only the statements like I think like that. The while reading, the return statement, it comes like that. So it becomes very difficult when we are reading it. in the class uploads actually.
Okay, we content
Uh,
whatever the lectures are
yes,
uploaded.
yes, yes, yes. Yeah,
So
yeah.
what do you are
Is
facing any issue with the video or with the transcript?
no, 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 no. The grammar, no. What I think it's okay, something like that. While reading, it comes like that. So the connectivity gets lost. It's not like we are in a live session, no. So if we read the transcript, sometimes there is a
Okay,
gap actually.
in the
Is
transcript,
there any? Yeah, is there any PPT or a PDF file or no? It's
no,
just only the conversion, audio conversion to text actually.
no, those are not available because that is converted from the, like whatever the transcripts are there, those are converted
Audio
from the
conversion.
video. Yeah, those are converted from the video to this. So those are
Okay, okay.
only like whatever the in the video is said, like whatever the grammar
Ah,
and everything is said, that is the recorded is there.
okay, okay, okay,
So
okay.
that's why, and the PPT and all, because that is also those sessions are taken on the some writing pad and that. So those things are, I think, is not available, like
Okay,
everything in the
okay.
written. But if you will go to the
So it's
video,
only the audio transcript as it is. As it is, it is available. Only
no,
the as it is.
in a transcript in the word file they have given you the all this thing.
Yeah, it looks like we are interaction is there, personal interaction is
Yeah,
there. I
that is
think
the
it's
same as the
okay. So
personal interaction kind of things,
yeah.
not the like the professional kind of thing, only like related to the like whatever the content is there.
Mm,
So that is the
mm,
class
mm,
kind of
mm.
thing, because that's
Yeah.
how the lecture is content.
Okay.
So you will, if transcript is not okay, if you will go to the lectures, it will be also okay. I think everything is mentioned in the lecture itself, video lectures.
Ah, okay.
So is there anyone has any doubt, or should we conclude the section?
Yes, we can conclude the session.
Okay, thank you everyone. So
Thank you so much, sir.
Thank you.
Thanks. These sessions are very nice, actually, very helpful, actually, to
From my,
understand the concepts. Without these, discussions, we cannot understand the theoretical concepts. Without
yes,
these
yes.
discussions, it's very,
That,
very useful,
this
actually.
is the main purpose of the conducting the session, so that you will.
Yeah, very useful, actually.
Okay.
thank you, brother.
Thank
Okay.
you, sir.
So see
Thank
you
you.
next week.
Thank you.
Thank you everyone.
Thank you. Thank you.
Okay.